Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Adam Haziq bin Zal Amali, 1232109.
And my name is Muhammad Tufid bin Zahdi. My matric number is 12322 and 9093.
And my name is Muhammad Fakir bin Kazizam, and my matrix number is 1232117.
So today we are doing our experiment on microprocessor and embedded system. So let's see our result.
Yeah.
The objective for this experiment is to construct assembly language code for solving problems using Microchip Studio Integrated Development Environment (IDE).
Advantage is, first of all, Microchip Studio offers the strong MCU support by coating a wide range of AVR and SAM microcontroller. So after that, it also provides an integrated tools, mean that the compiler, debugger, simulator and programming tools are all in built-in. So the last one is Microchip Studio is completely free to use, which is a huge advantage for students and anyone with a limited budget. However, there are also a few disadvantages to consider. First, the software is Windows only, so user on Mac or Linux will need a workaround like a virtual machine. So it's only can use in Windows. Secondly, Microchip itself states that Microchip Studio is not recommended for a new design, so it might not fully support the latest device. And the last one is simulator support is limited. Not all microcontroller can be simulated in IDE, which reduce flexibility or testing without hardware. So, as conclusion, Microchip Studio is a powerful and convenient tool, but it is important to match its strength and limitation with your project needs. That's all.
So for this experiment, we are using Microchip Studio. At first, when we open the Microchip Studio apps, this interface will pop up. And next, we click New Project and choose AVR Assembler Project to use assembler language. And at here, we choose Atmega 328P. After continue, this interface will pop out, which is the space for us to write our coding here. Then at first, we run the example program there, and then we need to choose or select our debugger, and we choose simulator. And next, we can proceed with our coding in the space provided. So this is for the problem 1, that we have to store a 7-digit student ID number into RAM starting at address 0 multiply 100. So in this problem, we have to use LDI and STS. For the LDI, we have to load the constant value into the register, and for the STS, we have to store direct to the data space. So let's try run this program. So the first one, it will load the value of 1 into register R16. So as you can see at the bottom left, the value of 1 is put into the R16, and so the R17 they equal to 2, R9, R18 equal to 3, R19 equal to 3, R20 equal to 2, R21 9, and R22 3. So then we have to use STS to store direct to the data space, right? So as you can see at the data register, you can see the value. Okay, let's move on to problem number 2, where we have to write a program to calculate the sum of two 8-bits number. So the first one, we load immediate the R16 equal to 9C, and the second one R17 equal to 0 multiplied by 64. And we add both number and put the value into R16. And then we store the value into the register. As you can see that that value contains CHZ, which is it contain the carry and also the value has a 0 after the additions. Let's move to problem 3. So problem 3 required us to execute subtraction R1 R2 20 times by using a loop. For problem 3, we use LDI R1620, which is the function to load the value of 20 into register number 16. So LDI R170 is the method we use to load the value of 0 into register number 17, and this is unnecessary. Next, we put label L1 for the next function so that we can do the loop by using this label. In this label, we use the function sub R1 R2, which is the requirement of this question just now, and we put decrement R16. So the decrement R16 is used to make sure that subtraction R1 and R2 happen 20 times, as we have declared the value R16 is 20. So next, we use BRNE function there, which is branch if not equal to. So this function will make the coding jump to the L1 back until the condition is satisfied, which is when decrement of R16 is equal to 0. So as you can see above, the value in register R16 is decreasing by 1 from the value of 14 in hexadecimal, which is 20 in decimal, until value of 00. Last but not least, we put label 2, jump L2 to make sure the function stay there forever. Next, we move to problem 4. So problem 4 requires us to compute the sum of 15 plus 14 plus 13 and so on until 1 by using a loop. So based on our coding above, we are using LDI R1615, which is used to insert the value of 15 into register 16s, and also LDI R170, which insert value of 0 in register 17. And next, we put L1 as a label. So label L1 will be used in our loop. Next, we put the function add into our coding. However, during our lab session, there are some mistake there. It is supposed to be at R17, R16, so that the value of R16 will be added into R17 instead of value of R17 add to R16. So that the value of R16, which is 15, will be decreased 1 by 1, and then we could add 15 plus 14 plus 13 and so on until the value of R16 become 1. The value of total sum will be stored in register 17 and should be displayed on R17. But somehow, due to the mistake that we have made, the result of the calculation does not be displayed at R17. Instead, the value of R16, which is 15, is decreasing 1 by 1 until it becomes 0. Last but not least, we put label L2, jump L2 to make sure the coding stay there forever. Okay, so let's move on to the problem number 5, where we have to compute the value of 5 plus with 10 and so on until 25 plus with 30. So to tackle this problem, what we have to do, we have to load the value of 0 into R16 and also that value into R18, which is both of it has the value 0. So and then we enter the loop where we have to increase the value of R16 by 5 times. So we add the value R18 with the R16 and put that value into R18, and then we load the value of 30 into R17, and then we subtract the value of R17 with the value of R16, and then we check the conditions of Z whether it's 0 or 1. If it's 0, then we have to repeat the loop we have to repeat the loops until the value of Z is 1. So done.